Hello, hello, can you hear me, sir? Hello.
Yeah, yeah. Hello. Can you hear me?
Yes, sir. Yeah, I can hear you, sir. Can you hear me?
Yeah, yeah, I hear you. Okay, we'll
Okay,
start.
sir.
Recording in progress.
So I think your today network connection is good. Yeah.
Yes, it's good.
Okay. Can you see my screen?
Yes.
Okay. So hi and welcome to the fifth day's training session from beginners to advanced course on Google Earth Engine. So I am course coordinator. And this is our full course content. Already done the four class. Okay, so today is our fifth class, and next sixth and seventh class we will focus on the land cover classification. Okay, we will complete all of the part for the land cover classification next two class. Okay, and basically today is our fifth class, and in these classes I also try to focus on air quality monitoring and how you can easily handle with the different types of data using the Google Earth Engine platform for air quality with different gases, nitrogen dioxide, sulfur dioxide. Okay, and how you can easily make the time series chart and how you can easily get the time series data in CSV file format. Okay, and you already know about that when you work with the chart. Okay, this chart is only possible for the small region. Okay, but when you want to make the chart for the big region, this it's not work in Google Earth Engine platform for making the chart. Okay, so when you want to work the NDVI map for MODIS, then you can see a small region is we can easily get the chart, but when you want to make the chart for NDVI for the whole country boundary for India, you cannot get the chart. Okay, so that then we move to the CSV. Okay, we need to get the data CSV file format. Okay, and it's also possible, and all of the data will be same. Okay, for the same procedure we can follow for take the all of the data for in a CSV file format. Then we can get the all of the time series data in Excel file, and then we can easily make the chart using the Excel file. Okay, when you can get this data, then you can easily make the chart in your Excel. Okay, so mainly when you want to get the data in big region. Okay, it can be NDVI, NDWI, or air quality parameters, different types of nitrogen dioxide, sulfur dioxide, whatever. When you want to work with the big region and you need to the data, then you move to the CSV file format. Okay, you need to make the CSV file format. Okay, so in this time, in these classes, I also try to show you this part, how you can easily get the data or time series data in CSV file format. And then how to convert. You can suppose in this time when you work with the different types of gases, you can see this gases unit is mole per meter square, and you need to convert the molecules per centimeter cube. Okay, or if you need to the another conversation, suppose you want to measurement the total emission in ton. Okay, how many nitrogen dioxide will be emitted in a particular time period, you want to calculate this in a ton. Okay, then you need to also conversation with the mole per ton. Okay, so we also cover all of the things one by one, and this is our fifth day course content. So first of all, you can see this is the demo map of methane concentration map of Kuwait city, and another is the nitrogen dioxide concentration year of 2020 month of January. Okay, for the nitrogen dioxide. Okay, so mainly we will do everything in Google Earth Engine platform for process the data. Then we can just easily export this data as a TIFF format. After this, we can easily use the ArcMap software for making this map layout. Okay, so I hope you can also do it, and I also try to show you the process. And you can see this is the another things, and this is the same way for nitrogen dioxide levels rebound in Bangladesh. So before lockdown, during lockdown, and post lockdown, this time duration we will get, and we can get all of the things from the Google Earth Engine platform as a TIFF format. Then we can easily make with the ArcMap software for making this map layout. Okay, so first of all, air quality monitoring. So mainly in this time, here we use the Sentinel-5 satellite data. Okay, so Sentinel-5 satellite data, this satellite will be launched at the year of 2017. Okay, so we can easily get all of the air quality parameters, okay, which will be available in the Sentinel-5 sensor. Ozone, then nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. Okay, all of the gases we can easily access from the Sentinel-5 dataset. Okay, and this is the Sentinel-5 dataset. For we can easily access all of the data from this link. So I simply copy this link for access the all of the dataset. So here you can see all of the data set, and this is the Sentinel-5 mission instrument to collect the data useful for accessing the air quality, and mainly it focus ozone, methane, formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. Okay, these gases. Okay, so here you can see all of the data set. So this data set is for the aerosol index, cloud, carbon monoxide, formaldehyde, nitrogen dioxide, then ozone, then sulfur dioxide, and methane. Okay, we can easily work all of the data set for my own region. If you want, you can also make the time series chart. If you want, you can also get the time series data as a CSV file format. So suppose in this time I want to work with the data set. This data is I want to work with the nitrogen dioxide. Okay, suppose I want to work with the nitrogen dioxide. So I simply click on this data set, and all of the process, all of the gases will be same process. Okay, so I will try to show you this in nitrogen dioxide. So first of all, you can see we can see here the dataset availability date, dataset provider, Earth Engine snippet. Okay, suppose in this time I will try to show you that how you can easily make the time series chart for a small region. Okay, and when you want to make the big region, then you can see this chart will be not appear. Then we move to the CSV file format for getting the data set. Okay, so I simply open a new code editor. So you can see, suppose I want to work a region, a small region, because I want to make a time series chart. So suppose in this time I work with this region for Dhaka city. Okay, this is my region of interest. I want to get from this time series chart about nitrogen dioxide concentration in a particular time period. Okay, and I want to get this data from the time series chart. So I simply click to the import. You can see, and I also give this is the area. Okay, and then we also need to import our data set. So in this time you can see I simply copy this Earth Engine snippet from here and provide a variable name. Suppose this variable name is that data. Okay, I store this image collection in this variable. Okay, so now I want to filter. I want to filter different way. First of all, I need to select my specific band. So I simply use here the select function, and then you can see this data set has a different band. Okay, I want to work with the nitrogen column number density. Okay, so I simply copy this nitrogen number column number density and paste in here, and then I also filter a specific time period. Suppose I want to filter I want to observation the nitrogen dioxide concentration in a particular time period. So I simply use here the filter date function for get my specific time period. Suppose I want to observe the year of 2020, 1st January. Okay, and I also want to observe here the 2020, 1st January 31. Okay, month of January. I want to get this change. Okay, this data set. I want to make the chart with this time period. Okay, so then I also need to use here a function. It's called the filter bounds function, so that my whole collection or whole collection of the nitrogen dioxide, it will be intersecting with my area. So in this time I simply use here this area. Okay, and now I want to get this data, suppose, and if you want you can also show this data in here in your region. I simply use here the map dot add layer. Okay, and then I simply copy, and I also focusing this shape file. I simply use here the map dot center object, and it is the area, and I zoom level 10. Then simply click to the run. Okay, we can get this data as a tiles because we did not use any clip function in here. Okay, we can get here totally, you can see, as a tiles images. And if you want to check how many images will be available in your area, you can check it. I simply use here the print function, and you can check the data. I simply use here the size function, then click run. So you can see here only for the month of January, here we can get total 418 images. Okay, and in these images, actually this is the raw image. Okay, this is the totally raw image. Here total 418 images will cover my region of Dhaka city. Okay, so it will be appeared. So total images. Okay, so now I want to, suppose I want to work, you can check when this image will be captured. I simply print my information of this data. Let's see. Feature, you can get this data. Some data will be take at the 1st January. Okay, 1st January. Some data will be take at the 2nd January. Okay. Then some image will be captured at the 3rd January, 4th January, 5th January. Okay, all of the images will be taken in this month, and we can get here the total 418 images. Okay, suppose in this time I want to make this chart from the 418 images, and this image will be captured the different time of the month. Okay, so that's why I want to get from here the mean image or average image. Okay, and I want to make the chart for the average time series chart. Okay, average pixel value chart. So that's why I simply use a function. It's called the mean. Okay, and then I also use here the clip function. So that's why it will be clipped with my area. Okay, then click to the run. In this time here you can see I can get only for the one band. Okay, all of the data set, all of the image created the pixel value as a created the average one image. Okay, so in this time all of the images here I can get first of all total 418 images. Okay, between this month. Okay, and I get from here the I want to calculate it here the mean. So that's why I simply get all of the images as a mean. I can get only for the one image, okay? And this is my average or mean pixel, okay? Which it will be created from the total 418 images, okay? And if you want, you can also use here the visualization parameter. Suppose in this code they are already provide the some visualization. I simply copy and paste here. And then I simply copy this variable visualization parameter variable name and paste it. After this, click to the run. You can see we can get totally red map, okay? Because this visualization and here we can get this result is not the same, okay? Here the mean and max will not be same, which you can see point, and also you can see 0.002, okay? It will be not mixing, so that's why we cannot get any distribution or any different from one pixel to another pixel, okay? So I want to check what's the pixel value, mean and max pixel. I want to simply click to here. You can get the result from here. Here you can see this result is the 0.0003, and I also select from here. Suppose also see. So I simply copy this value because I want to show the visualization parameter. Okay, so now you can see it will be showing some different color with the some variation, okay? We can easily identify in here, and when I simply click to here, you can get this result, okay? When I simply click to here, okay, we can specify the different region, okay, for the different concentration of the nitrogen dioxide. And when you download this image as a TIFF format, then you can get the total raw data, okay? Which pixel value, it means that it will be start from the 0 mole per meter square. You can see this unit is the mole per meter square, okay? And up to max 0.004, okay? This mole per meter square, okay? So I want to get this result between this range, okay? In here it's only showing, but it has also raw data, okay? Which raw data, when you want to export this map as a TIFF format and open the ArcMap software, then you can easily get this raw data, okay? It will be actual data you can easily get from here. But in this time, which value I want to set this value, and so that's why I want to get the pixel value look like this. Which value I set, I can get this according to this value, okay? So you can see this is our map, and now I want to calculate it from here the time series chart, okay? So when you want to calculate the time series chart for making the CSV file format, and in this time you can see this is the small region, okay? So that's why we don't need to CSV file format, okay? We can easily make the chart and work with it, okay? But when you want to the big region, and I also try to show you that how you can easily make the get the CSV file format for the big region, okay, for getting this data.